Cool. We'll give everybody a bit of time. Oh, well. Just saw a name pop up. Menshawi. Is that the Menshawi from Nottingham?
Yes, hello, Paul.
Hey,
How are you doing?
good. How are you? It's been many years.
Yes, finally meet again.
Yeah, definitely. Yeah, really nice to be reconnected. We're definitely overdue a catch up. Yeah, Menshawi and I did our PhDs together many years ago. And great to see you still working in education. Are you back in Egypt?
Yes,
Nice, very nice. Great to see you.
yeah, thank you.
Guys, there's also to point out this is the third session, and you can catch up on sessions 1 and 2 on the website. I'll put the link into the comments.
Okay, thanks, Sarah. Okay, should we maybe get started then? Because there's quite a lot going on. I have to confess, we did this as a three-parter. We originally had 4, but then with the summer break and stuff, so there's quite a lot of material to cover. And I think the last few sessions we've been kind of looking big picture on, what is AI? How does AI, what does AI for education even mean, and some founding principles. And then we dig in a little bit to some of the challenges, including how do we get our own content and knowledge in. So as Guy said, for people that want to catch up, sessions 1 and 2, you can go back and re-watch the recordings as well. Today I wanted to talk a little bit about equity inclusion and how people are trying to shape AI tools to essentially build for the poorest, because to recap, we're all very, very excited about this technology, but we're all working in places which are facing greater than average challenges. And one of the things we're very conscious of is if we don't build for these contexts when we start, then the mass market ones will simply not work. So I wanted to talk a bit today about equity inclusion. I also wanted to talk a bit about evidence and benchmarking and what evidence looks like in the context of AI as well. And this is simply because one of the things we've realized is, or people ask us a lot, is how do we know what's good? So as this new technology comes, how do we make sure that it's based on evidence and that it's ultimately improving learning? So we'll come back to that as well. Next slide, please. So for people that joined the first few or that know us, a lot of this work came out of a kind of concerns that the technology has got a lot of potential, but there's a real risk that children in low and low middle income countries get left behind. And this can be through many ways. We know that without support, they can be excluded through languages because, and I'll talk you through it, these technologies are trained on the internet. The internet is largely English. So there's a real risk that people that speak non-English, basically, end up being excluded. There's a real risk that people are excluded through not being in the training data. And I keep repeating this, but these systems are really good on things they've seen. And the reason why they've become very powerful is because they've seen a lot. So when we say large language models, it's because they've read trillions of words. But if your words or the words of your local community, your context are not in those words, you can be excluded. There's also a risk in terms of the costs. And the cutting edge technology is always quite expensive, and especially for the big models. So there's a real risk that when this comes, it will only be affordable to the rich and not to the poorest children. There's another risk here, which is infrastructure and digital divide. So even when it exists, we know there's a gender bias in access to devices. Here, we're going to talk very quickly at a high level on how people are thinking about offline language models for people who are excluded through a lack of internet. There's also a couple more in terms of digital literacy. So people get left behind simply because they're a bit scared. They don't really know how to begin, or they don't understand the technology. So there's a whole stream of work on digital literacy and making sure people are
super coming. I'll find out. I think she has gone.
Finally, there's the more traditional kind of exclusion of children with disabilities. There's also a lot of potential here for AI to actually help and target specifically with disabilities, mostly because of its ability to do transcription and turn voice into words and words into voice, which for the visual or auditory impaired is very important. Okay, so I'm going to run through all of these very quickly. It's a very high level scan, just in the interest of time. And then I wanted to talk about evidence and benchmarking. Next slide, please. Okay, so I think on the next slide, on the language issue, this is something which will be close to the heart of many people on this call, especially people that come from countries with multiple languages. And those languages sometimes are not even written languages, they're spoken languages, and they're very important to culture and very important to education. And one of the big challenges with generative AI in particular, language models, is the core training sets, such as the Common Crawl, and you'll hear this a lot. The Common Crawl is essentially scraping the internet, and it's in English. 44% of the internet is in English. Even languages like French and German and Spanish and Arabic, which have got a very high number of speakers around the world, do not have as much content written down, published on the internet. So if you remember here that AI systems learn by observing and then predicting, if your language isn't in there, then it's very hard to predict. So for education, this is very important because we know that mother tongue instruction is key for foundational literacy and numeracy. We also know that quite often teachers have limited English where it's not their first language. So just relying on English as a default language can come with challenges. So if we don't figure out how to get local languages in, then over time, we potentially exclude large number of people. So I think there's a big question in terms of how do we get AI systems to use other languages? Next slide, please. The good news is here, and again, this is just a very high level, we will write a bit more on this in the future. There's a lot of people who are essentially trying to tackle this problem. So I see three kind of categories of solution here. The first one is AI is actually very good at translation. So even this week, I think Google just added another 110 languages to Google Translate. So one of the options people are exploring, especially in circumstances where you don't need an instant answer, is if you can use generative AI to create your content and then use traditional AI translation software to optimize afterwards. So Robots Mali did this in Mali when they were trying to create new textbooks. And there's quite often, I think, a big question is, do we need the LLMs always to be generating in languages, or should we take advantage of the really advanced AI technologies which already exist for translation? So that's kind of solution set number one that people really actively exploring. The second space is people are building the models to be really good in other languages. And this does actually include the large big technology companies who are actively trying to expand the language capabilities of the models they're in. This also includes smaller spin-offs, such as Lelepa AI, who are trying to optimize language models for Africa. So they are specifically trying to build for low-frequency African languages. So again, this is a very active space and one that people are looking on. The final solution here, and this might be a good solution for people with lower barriers to entry, is what's known as in-context learning. So if you remember the last session where I talked a bit about how you can improve and how you can get your own content into language models, this problem is again one of getting your own content in. The only difference is instead of your content being specific teacher training, it's a language. So when we talk about training models in other languages, what they're essentially doing is creating a corpus of text in that language, which they then use to train. You can also do a very similar thing, but in context. And in context here literally just means that you do prompt engineering. So you just literally put it in the prompt and get on with it. And Gemini, Google's large language model, has a context window of 750,000 words. So when they publish this, actually, in the technical paper, one of the examples they cited was a very, very small language in Papua New Guinea, which they basically managed to get to very high translation quality just through passing it in context. So in summary, languages is a very big issue for these models, and again, it's certainly a smaller language, but there are kind of solutions kind of being developed as well. Okay, next slide, please. So I won't dwell too much on this one because we covered it at length last week, but I think it is important just to kind of go back to it. One of the biggest ways that people are being excluded or possibly excluded is in this training data. So it simply doesn't reflect the education context. And there's lots and lots of research here in terms of how do we bring additional content into AI models. So we talked last week about RAG models, where you retrieve what's relevant. You use this information to augment the generation of the answer. You can also do fine tuning, or you can also do prompt engineering. So again, we covered this a lot at length in session 2, so I'm not going to go back over it. But the key thing to remember here is it all starts with curating high quality, locally relevant materials. One thing which I often say to people is like training data is everything. So it's your textbooks, it's your teacher guides. If you have a really good process for how you train people, that is training data potentially. So this is where it starts. If you're worried that your scenario is being excluded because it's not in the training data, the first step is working to make sure that it's machine readable so it can be put into the training data as well. Okay, next slide, please. So the other kind of obvious one, and again, I'm not going to go into very much detail here, but it's something for people to be aware of, and it links through to the evidence part and benchmarking, which we'll talk about later. Basically, the larger models are just better, basically. So if they've seen more words and they've seen more connections between words, they're generally better at predicting words and at their use in creating content, but they're a lot more expensive. So smaller models are cheaper, but generally not as good. And one way that people look to save costs is essentially to use these kind of smaller models. One of the big challenges here is we're only just figuring out ways of benchmarking. So this kind of question of how much does performance fall when we swap out kind of models is basically just an emerging field, and it's going to be very important. Just a kind of graph there just shows the difference in cost between using GPT 3.5 Turbo and GPT-4. And as you can see, it can be at least 10x cost. So one of the things for people to be aware of is quite often people do try to save money at scale through using smaller models, and it's important for us to figure out exactly what the impact of this on the education processes are. Next slide, please. So as I say, costs are a worry, and this slide was more targeted for people that are interested in building or procuring kind of AI models rather than the policymakers per se. But I thought it is worth putting in. One of the things that people are doing is they are trying to keep costs down by taking a lot of steps, and the more we can keep costs down, the more we can keep prices down for the end consumer. And make it more accessible at scale. So there's a number of ways of doing this. The first one is hosting your own model. So you essentially don't pay for the OpenAI costs. You basically build and host your own models. This can save you a lot of money at scale, but in the short run, it may actually cost you more money. And one of the things when you're trying to decide what to do, or policymakers are evaluating options, there's a tendency towards open source. One of the points I always make to people is open source is not free. Open source means that you're managing it yourself, which can save you money in the long run, but it also means people. And people cost money, and this is an area where skills are quite scarce, which means that your costs in the long run could actually be higher. What I often say to people there is, make sure you know exactly what you want before you start building, and buying in the short run while you get a sense of the quality is never a bad thing. So there's quite a lot of ways people are exploring here to kind of keep costs down. As I say in conclusion, we need to think through what is the impact on quality of these cost trade-offs. And the other point I think finally to make here is that yes, these things do cost money, but so do people, so do cars, and so do petrol. So for example, if you're doing on-demand WhatsApp support for teachers, then it might seem expensive to be paying $3 a month. But if it costs you $30 for 1 day's training, then you need to think through what the counterfactual is we're comparing our costs against. Okay, next slide, please. Oh, actually, any questions at that point before I go on to the next stage?
May I?
Yeah, of course. How are you doing?
This is Huma Arshad.
Hey.
Actually, this is not a question. This is a small input from my side regarding this translation kind of thing. Actually, when at the arrival of ChatGPT-4, when ChatGPT-4 will be your companion, 24/7 companion, and it can read your room as well. So I think this translation problem is automatically resolved. If I'm correct me if I'm wrong, or if I'm thinking like that. Thank you.
Sorry, you're thinking, Huma, that GPT-4 will help solve a lot of that problem, yeah?
Yes, that's what I'm thinking. That's what I have assumed actually. That's what I have seen. I've watched the videos related to that, and I have seen myself. So this is my question regarding, particularly for translation.
Yeah, so you know what? It completely depends who you are. So I think if you speak Hindi or Bengali or Amharic or Swahili, then yes, definitely, the larger models will ultimately get trained for you, simply because there's sufficient numbers for people to have that kind of big push to optimize it for those languages. I think if you're a very small minority language, then the bigger models might take a good few years.
Okay.
So they might get there, and certainly for the very large markets, they've got there already, you know. And I think the other thing to be aware of is when it comes to the hyperlocal, even in, say, Swahili, the differences between Kenyan and Tanzanian Swahili, you know, could make a difference to how people feel and how people interact with the models as well. So I do agree that for the high frequency languages, the bigger models are good enough, you know. Whereas I think that the last mile, and be that small languages or local nuances, is where we'll have to do continued thinking.
Thank you.
Okay, next slide, please. So I just wanted to talk through a little bit on the internet issue because I hear this quite a lot. And people are saying, oh, how do we get GPT-4 to run offline? And the thing to say is, I couldn't get GPT-4 to run on my computer, it would completely break it. Generally, if something is, say, a 70 billion parameter model, then you need double the number of the amount of RAM to run that. So you'll need like 150 gigabytes of RAM before you start optimizing. So these models are very, very big, certainly the God models. And one of the things we know is that access to devices and the internet has definitely improved, but it's still not universal. And one of the things I talk about, and the diagram here is quite complicated, but it just explains how a teacher chatbot actually works technically. And one of the things here is the interaction you'll see in the green box between the user phone and the AI system is quite small. So one advantage of language models is they literally just send text. And text is quite small from a data perspective. So if you're just sending, even 1,000 words, you'll have noticed this. If you just have a Word file and it's, got 1,000 words in, it's quite small. It's only when you start putting images and all the other stuff in that files get really big. So because all the heavy lifting is done in the cloud, I think that this technology, by kind of default, is a bit more accessible than the previous ones, which did require a lot of devices, right? So I do think that even though people might be excluded, the fact that these language models use small amounts of data is a really good thing for accessibility, because you can now access it through WhatsApp, through very simple web interfaces, or however. But if we really, really want to reach the most remote and no connections exist, and this is the case in 12% of Sierra Leonean schools where we work, then you do have to think about offline as well. Next slide, please. So a lot of people are trying to kind of think this through, not just because of the whole offline, but also I think people will have noticed that, Apple, for example, is spending a lot of money trying to make AI systems work on the phone. So are Microsoft, and so are many, many others. And they're literally doing this because, well, one, data security, sending stuff to the cloud and sending stuff outside the country might not be what people want. The second is that computers are expensive, and to run big computers is even more expensive in terms of power, but also in terms of the chips and the hardware. So people are trying to get the size of these down, mostly to save costs, but also expand it. I just put a couple of things here for people to be aware of. We're not going to go into the technical details, but there's really two tricks that people are trying to do. The first one is, and we went back to it before, if you remember, AI systems work by turning words into numbers. And you literally just save them as less precise numbers. So the basic models save them as, like 22-digit numbers. You don't need that, so a lot of people are just trying to make it smaller there. And then the second trick that people are doing is they're not just saving kind of the words less precisely, they're also saving less connections between the words. Because if we remember, AI is not just about the words by themselves. The big breakthrough was the paper, what was known as attention. Attention was all that you need, it was called. And essentially what that does is it says, don't just look at the word, look at the words around the words and pay attention to how they connect. And what this does, it is allows context to come into each individual word as well, and allows a lot more advanced processing. So if you save less connections between words, it means you have less nuance, but it's still okay for very simple things. So you can save them less precisely, and you can save fewer connections and fewer words as well. And when people talk about, and I put an example here of the meta model, when we talk about the number at the end, so this is meta llama 3, so that's the third version. And then the final digit, 8b, tells us how many parameters they have. So 8 billion parameters there. The other models they have available are 70 billion parameters, so nearly 10 times as much. So 10 times as powerful. Okay, so just one thing for you to be aware of, when people start talking about, 70 billion parameters or 78 billion parameters, that's just a way of them explaining essentially how much information is saved within the model. And bigger is usually better, but it's more expensive as well. Next slide, please. Next slide, please. So, as I say, because of these cost reasons and also because of the accessibility, people are actively exploring putting small language models on their phone. So the biggest technology companies are doing this. So Microsoft have got their own model, 5.3. Meta have launched Llama 7 billion. Apple have also got a whole range of models which they've open sourced as well. NVIDIA have got small models which they've open sourced. There's a real push and competition to getting these on devices and on smartphones. One thing that we are saying is, well, that's great, and it's amazing that you can have this offline on an Apple device, but they cost $1,500. It's not going to be the case that we have them for all the children. So what we have been trying to do and working with people across the sector is say, can we get these models working on the type of infrastructure we would see in sub-Saharan Africa? And we've been working with Beaky here to experiment with this on Raspberry Pis. They do School in a Box, where they have a learning management system in refugee camps in rural communities. And what we've tried to do with them is get these language models working. And they do work. And what happens is they're just slow. So I think they can generate 3 tokens per second, which is about 150 words per minute for people that think in terms of EGRA. So it works, but only 1 or 2 people can use it, and it's quite slow. So one of the things we're thinking about there is what tasks don't need fast responses. So which ones can we do asynchronous? And even within this, which tasks don't need a large corpus of knowledge? So which ones can we just narrow down, have a narrow range of knowledge, and then use this and put it offline for people to use as well? So again, lots of innovation in this space and lots of thinking in this space as well. Next slide, please. Okay, so this one, again, I'm not going to dwell on too much, but I think, well, these training courses are part of this as well. But new technologies do come with new challenges, basically, and people take a while to get used to how it works. They quite often can be overwhelmed by these new technologies. There's quite a lot going on. It's seemingly fast changing and it's seemingly quite complicated. And if we don't work and support and help teachers and policymakers and people in ministries, then we're not going to solve this problem. And a lot of the time, they will be excluded by this as well. One of the things we've been thinking here, and when we ask teachers, I think 75% of them are not into early on and never heard of generative AI technology. So it's really important that we help them navigate and we help explain to them in simple terms how exactly AI works and how it can best benefit them. So we started doing some prompt writing guide for educators. There's also UNESCO. We're doing a lot of good work in this space as well in terms of teacher competency frameworks, and so on and so forth. But I think that over the next year or so, we'll be increasingly seeing these kind of AI literacy roll out at scale. And it'd be great if everybody who was in this training course can be an ambassador or a champion and explain to people that they don't have to be scared of this technology. You know, all it's doing is predicting, and share some of these kind of key messages. Okay, next slide, please. Okay, so I'm just going to talk a bit about something which is kind of very dear to our heart, and then we'll take a little bit of a break for questions and then talk through some of the evidence and benchmarking. I think I mentioned before that, you know, like children being excluded through marginalization factors is sadly very common in education. And we worked on this for many years, something very dear to the hearts of everyone here. I think when we look specifically at children with disabilities, there's a real opportunity here from generative AI, and there are people working on these challenges, so it's important that people know this, simply because AI is very good at adapting and translating. So it's really good at basically transcribing students' or teachers' speech. And this is really amazing if you're visually impaired or hearing impaired. And one of the things you can do is create audio from text. So if you go on to 11 Labs, which is a commercially available software, and basically record your voice, you can then pass through it whatever you want. And even people are experimenting with like Be My Eyes, where they're essentially having live recordings, which then get kind of transcribed, or vice versa as well. So I think that there's a real opportunity here for children with disabilities to take advantage of this kind of text to voice and voice to text conversion. Again, notwithstanding all the other challenges as well. This can be applied to videos. This can even be processing sign language movements as well. Next slide, please. So, as I say, there's many possible kind of applications, and certainly many which excite us in terms of inclusion and disability. Some of this is, you know, like how do we, when we're building these models, and we keep coming back to how do we get our content in? How do we make sure that inclusive education training resources are there? So when we're building these new AI-driven systems, let's make sure that we incorporate these kind of inclusive education systems front and center. There's also a lot of stuff on predictive analytics as well, actually. So one of the things which AI is quite good at is spotting patterns, and certainly spotting deviations from patterns and the norm. And you've always got to be careful in terms of stigmatization and such. But some of these technologies did come out, or do come out, of essentially helping diagnose reading difficulties early as well. One of the things, BookBot, who I think we mentioned last time, is an adaptive learning app. And that was actually developed to help children with dyslexia read at their own pace. So if you're in a big classroom setting and you're reading very slowly due to dyslexia, then you know you can struggle and you can be forced to go ahead at a pace which is not your natural pace. If you're having the more individualized AI-driven adaptive approach, then you can basically learn at your own pace and unlock some of those challenges. So these kind of predictive analytics for, you know, identifying, but more importantly, when you combine this with the adaptive learning, can be very, very powerful in terms of children with different needs in a classroom as well. There's also a bunch of moonshot stuff, which is quite far away for a lot of classrooms we work in, but certainly have been seen to be quite good in the US as well. So VR, robotics, alternative learning environments has been a lot of successful innovation and research and development there as well. Next slide, please. So I think here we just put, this is just a really quick mapping, and we need to update this actually, because every time I look at it, I remember more. But there's already a lot of innovation happening in this space in Kenya, in Nigeria, in Mali, in India. There's also an organization I was looking at the other day called Benitech, who are looking at how we can do image recognition of equations which might seem quite niche, but then if you remember that, textbooks have pictures and equations in it, if AI systems can't do equations, how do visually impaired people learn mathematics, So you do need to have that small scale niche innovation. So there's already a lot happening, and, we can share some of these examples. Next slide, please. So, as I say, one of the things we often say to people is these things work better when you build for them from the start. And these are some of the kind of thoughts or concerns which I was thinking about when I was speaking on this. One is when we think about hallucinations where the models get it wrong. Obviously, the first part of advice to people is, well, quality assurance, use your own expertise. If you don't have a secondary quality assurance mechanism, do we need a higher standard of accuracy in terms of our products for building with people with disabilities? The other thing is, and I like to call this out at the very start, it will cost more money to build these applications for people with disabilities, simply because they were high frequency. It's going to cost you a lot more money developing a tool that is used every minute than it will be a tool that is used once per day. And I think we just have to accept that, and accept that if we want to reach the most marginalized, it does have a higher cost. It's also got higher benefits, by the way. We've just done a paper on girls' education, which shows that across a lot of Africa. We also need to consider model design here. One of the things which AI systems, as I say, are very good at is seeing a lot of examples and then predicting. We have to think carefully what it perceives to be normal, and especially if we have hidden disabilities or things which are not seen, and we need the system to have seen them. So we need to proactively design with inclusion and equity in mind as we evolve these systems as well. The final one is privacy and ethics, and we're not going to have time in these sessions to go through this. We did actually have some materials as well, which maybe we'll do a special session on AI safety, AI ethics, and all those things as well. This is accentuated when you start in talking about people who have additional needs as well. Okay, next slide, please. And as I say, I think there is a real risk that if we don't intervene and we don't start building with this in mind, that these tools will emerge to be unequitable and not inclusive. The good news is, and we've gone through all this very, very rapidly, but the good news is all of these are very active research spaces at the moment. So there's people working on them. There are some excellent people innovating and trying to solve these problems. So we are hopeful that if we do support these tools, then they can start being used for mother tongue instruction for all, not just the high frequency. They can have the high quality materials. They can be affordable, and they can be running in the corner of the room by people that know how to use them and know how to get the best out of them, and be used by everybody. Okay, I'm just going to stop, open up for questions on the inclusion, and then I just wanted to take time in the rest of the hour just to talk through evidence and benchmarking, which is something which is new in this space as well. Next slide. I think it should say questions, but I can't remember. Yeah, it doesn't. Let's keep on this slide. Any questions on that part? Huma, do you want to come in?
Yes, I just want a small comment. The thing is, for example, Cambridge is also working a lot on AI when it comes to education and when it comes to teaching and learning practices. And they have made these AI policies as we are working with Cambridge, so we got to know these kind of things. So I think things are going at the right direction. And when it comes to addressing inclusion and diversity, I think EA can do wonders as you are explaining. And the only hitch and the only problem can be the internet connections in those areas and how much load their laptops and their devices can bear. Thank you.
Yeah, No, I definitely agree there, and we'll come back to it in the next part. Has anyone else got any comments or questions on that bit before we kind of move on? I can't see any other hands, so maybe I'll just get the rest of the talking out of the way, and then we can come back to it. But I mean, one of the things, and next slide, please. One of the things we wanted to talk about here is like, how do we build to take into account some of these things which are known challenges? And one of the things we often hear is, you know, like what evidence is on AI? So how do we know this works? And the kind of the initial response, certainly for the last year or so, was it's far too early. We don't know. You know, these tools are too soon, and you know we're only just beginning to see. It's going to take a while. And one of the reasons, or one of the things we've been thinking, is this is because our current evidence frameworks in education focus a lot on children's learning, which is great because given the scale of the learning crisis, it's very important that we keep that laser-like focus on the children as the ultimate end users. One of the things that we realized, and people will hopefully begin to recognize this image, is AI for education is not about edtech tools, you know, on their own. So it's not about sticking kids in front of a tablet. It's about upgrading what we do in education using a new general purpose technology. And we're seeing many innovations appear across the whole spectrum of AI use cases. Some of this is personalized learning, some of which is teacher support, making things more efficient and engaging in terms of content generation, digitalization of that, or making things more accessible, lowering the price of marking or data analytics. So when we step back a little bit, we realize that there's essentially three things which are three possible outcomes or intermediary outcomes from AI tools. One of which is efficiency. So we do exactly the same thing. We have exactly the same output. We just do it quicker. So instead of taking, and I mean, a very simple example is an agenda for a meeting. You know, literally go on to Claude and say, give me an agenda for a meeting, here are the people. It'll give it you in less than a second, which you then edit and job done. Equally with lesson planning, if we're creating lesson plan apps, and then the lesson plan could be the same quality, but the teacher manages to do that lesson planning in 5 minutes instead of 1 hour. So that just saves them time. They may or may not use that extra time for education related things, or they may use that time to go and watch Spain versus Germany at the football this evening, and that's okay. Then they're a happy teacher, you know. So I think one of the things we need to be conscious of with AI in education when we talk about evidence is we need to get better at thinking about what evidence means, because it can be efficiency savings, it can be productivity where we're doing things better, or it could be unlocking new things as well, like adaptive learning, teaching at the right level for 100 children. Not possible, really, in terms of a kind of teacher remembering every single child's learning journey. Very easier to do in with AI. Okay, so one of the things we realized is our existing evidence frameworks focus on this productivity side. So we needed to step back a bit and refresh it. Next slide, please. So one of the things we've realized and been discussing is essentially we need 3 layers of evidence when we talk about AI for education. And AI is only one of those layers as well. And we'll talk through how that differs in some specific examples in a moment. But these tools, or any AI for education, really starts with, and I always come back to this, it starts with the education, you know. So like, what are we trying to achieve? Does this process or task have a solid linkage and evidence that it will help improve education? So the first kind of stream of evidence you need, or components of your evidence framework, is what's the evidence on the education intervention improving learning outcome? And here you've got a lot of traditional thoughts. Some people just do a simple theory of change. Some people do a RCT and then everything in between, you know, quantitative, qualitative. There's a lot of thought and time gone into what good education interventions mean. And then once you've got your education intervention, then you think about the technology. And Hummer, you hinted on some of the challenges here. Is your technology, well, does it work? Is it optimized for the context you're working in? Does it rely on large amounts of data where there's no data available? Does it require 32 gigabytes of RAM when most people have got 4? So there's a big stream of work thinking through, well, how does the technology work? And does the technology work? And some of this, by the way, is user interfaces and user journeys for children and learning and making sure that teachers understand the applications and things fed back. But you've got a layer of evidence in terms of how does the technology work. And then finally, and this feeds into this for some tools, you have your AI layer. So here, when we think about evidence, it's evidence on, well, does the AI work, you know? And here you have specific parts of, you know, like how you judge quality in AI. Generally here, people start with an idea, they prototype, then they go on to do what's known as benchmarking, and I'll talk you through in a minute what benchmarks mean. But essentially, when people say, how do we judge the quality of an AI tool? It's a benchmark. So is it accurate? Does it do what it said it was going to do? And then you have this feedback loop where people benchmark, evaluate, and adjust. And that can be through fine-tuning, retraining models, updating parameters, different content, or whatever. And then once that R&D is ready, then that AI part is launched as well. And one really important thing to take away from this is when we say we launch an AI tool for education, this might be a tool which takes you back into the tech, kind of does the tech work because it's now a combination, or this could be a process. So we're also seeing a lot of people using AI just in terms of going on to ChatGPT or Anthropic's Claude or Gemini and using it through a web browser to improve a process, and they're not building a tool. So for them, they only need to focus on the bottom part. There's also a bunch of people that are building AI tools who need to be focusing on the all three parts as well. Okay, so that is just a very quick introduction to how to think about evidence in terms of AI for EdTech. And the key takeaway here is if someone comes and they're like, we've got this amazing EdTech tool, you're like, well, what's your education theory? And then does your tech work? And then does your AI work? And you need evidence on all three streams to be successful. Next slide, please. So again, this is just that book put together in terms of how things work. One of the things when people are building EdTech tools or AI-driven EdTech tools is quite often you have a kind of pre-phase of your design in the R&D phase, which is where you validate your technology before you move into kind of how well it's used. So are people using it? What's the ratings? Are they using it as they're supposed to be? And then finally, you end up in this space where you look at evidence of impact on teaching and learning as well. So this is pretty much the same slide laid out in a different way. The key thing for people to be aware of here is when we talk about AI, we end up with this additional layer, which is the AI benchmarks and evaluation. Next slide. So, sorry, Siren, are we missing a slide? I think we might have a syncing problem, people. So Siren, if you just drop your screen, I'll start sharing my screen and it'll be seamless and we'll edit it out. Okay. So I feel like Dropbox can be a bit of a pain in terms of the thing.
How quality out?
Yeah, we'll edit it out, yeah. So I think one thing I just wanted to finish on for people is how do we judge quality for AI tools in particular? And generally here, you'll hear a lot about benchmarks and evaluations, essentially. So a benchmark is the way where in AI tools, you judge quality. It's basically the quality assurance mechanism. And if you go on to Hugging Face or any of the others, you'll see big long lists of numbers. And one of the earlier slides had this for the big models. People compete to get the best scores on these benchmarks to prove that they have the best models. And what this does is it looks and asks simple questions like, is it accurate? Does it have the correct content knowledge? Does it know what it's doing, basically? For education, we can also say, is this pedagogically sound? Most of these benchmarks are multiple choice. So when you dig into it, a lot of these are, can the AI system pass an exam? So if we give them the US bar exam or a maths examination for US students aged 18, what score does the AI system get? So a lot of these initial waves of AI quality assurance were essentially multiple choice benchmarks. And this kind of emerged because they were the easiest to compare, to quantify, and to interpret. One of the challenges you have in education is if we ask a question like what is a good pedagogy? Well, it's actually multiple pedagogies depending on the context and the people. And the best teachers are the ones that understand different ways of teaching depending on the day, and the same message repeated in 5 different ways can land differently with different people. So in education, the challenge we have is we do need a bit more nuance than simple like multiple choice things. And there isn't one right or wrong answer. And many factors determine the quality of a good teacher or the quality of a good chatbot, for example, in education. So it's quite hard to make just one test or one benchmark which evaluates all of these. What this means is that we're getting this shift towards kind of more nuanced evaluation. So we're seeing people over time developing essentially a package of benchmarks to basically judge quality against. I'm not going to go into why they're important, just in the interest of time. But the kind of headlines here are, we need some way of judging quality to provide goalposts for accountability. We also ideally do want to have some way of implementers knowing what's good. So how do you pick the best tool when there's going to be a plethora of options? And it's really important that you can do that in a transparent and quality assured way. And as I say, when we start looking at this, and we are actively working on this in the initiative, we realize that there's many different benchmarks needed and many different evaluation methods needed, simply because these tools apply to very many parts of the education system. And they also kind of need to encompass more factors, So one example here is we've seen Google release a new education language model. Within it, they had a series of evaluations or benchmarks, which looked at, does it give an answer or does it encourage a child to figure out the answer? Is the language that it's using pitched to the right grade level? Is it basically the right level of cognitive load for the child as well? And so on and so forth, all of which can kind of come together to enable you to say, well, of these components, these are the ones I'm really interested in, and these are the ones I'm going to judge quality on. So the way it's kind of evolving, and all this is quite live, is that what we're going to end up with is a series of benchmarks which people can pick and run against, which will enable them to judge quality depending on their use case and context. And I put some examples here. The ones in red, by the way, are the ones which we're investing time in. Some of this is content knowledge, content generation. Is it calibrated? This is going to be super important as people look to integrate it into their own national curriculum as well. Then you've got a whole bunch of stuff on accuracy and other things as well. Okay, so I think That is pretty much it. Sorry, just to finish, and I'm just very conscious of time for any last questions. People ask me a lot, is there any evidence that AI for education is helping? I should say the evidence base is emerging and it's coming fast. And we actually are tracking and collating this on the evidence library on our website. If you see anything missing, by the way, please feel free to reach out for new papers. 2024, there's been a lot of papers compared to last year. Just to kind of summarize this quickly, the accuracy of LLMs is getting pretty good across school subjects and a lot of improvements in maths. People are really working hard to try and get these models to be better at mathematics. In terms of processes and assessment in particular, we're seeing a lot of moves towards human level accuracy. So marking of essays, generating reading comprehension packages, very similar standards to humans as well, and including how they would code a classroom interaction, very similar to how expert humans would do it as well. There's evidence that AI-generated feedback can really help for teachers and for students, but when you dig into it, it's not the best. So even though it can help, there's still lots of potential to improve the quality of the feedback and really get the education experts involved in that process as well. Finally, we are seeing some emerging evidence on kids' learning outcomes. So Rory in Ghana showed very solid improvements in terms of learning outcomes, 0.37 standard deviations on primary and middle school maths as well. And we are seeing these kind of improvements in learning coming, especially from the adaptive learning. Anyway, I'm going to stop there. As always, it's an awful lot of information, but hopefully you can watch it back in slow speed and it's been informative. I'll just open up for any questions and then, yeah, let me stop sharing. Yeah. Maria, do you like to come in?
Yes. Hi, good morning. Well, it's good morning here in Peru. Sorry, I was just looking for more information. This is for a personal project here in Peru.
Yeah.
Regarding feedback and the effects it actually has when we use it as from the teaching perspective, I mean, and basically where would you recommend for me to find more information about the impact of the integration of AI for the process of providing feedback for especially children in middle years of school and secondary levels as well?
Yeah. Let me get back to you offline. Drop me an email and I'll basically just run a filter. I'm afraid to say I got up at 5 a.m. this morning to watch the UK election, so I can't remember the exact.
That's all right. I'm so
Yeah,
sorry.
but-
Could we have your email through the chat, please, if that's okay?
Yeah, someone can, Guy also, and just put my email in the chat. But basically, Maria, we've got your email from the registration. We'll share that with you and we'll also share it around to everyone else who are interested.
Thank you very
There's
much.
definitely papers on it. My mind's just gone a bit blank for the specifics of the paper. The other thing to say, Maria, is last week or the week before, we were messing around with a workflow to do this. So we've also got code available if this is something that you're interested in doing yourself. We've got the code all set up to do it.
That'd be awesome. Thank you very much, actually. And one more question, I promise. Where could we, is there a possibility for us to like apply to professional development courses with you guys, or perhaps like more CDP for us as teachers?
As teachers, it's a really interesting question. So maybe we're just in the process of formalizing our next wave of AI literacy offers. So it wouldn't be that you would apply. We try to make it as open or inclusive as possible, simply because with Zoom, there's no reason to have usage limits. So yeah, one thing maybe when we email is great, and this goes out to everybody. If there are particular topics you want us to speak on, we can spend some time getting up to speed on it and targeting kind of sessions on that. We also run basically smaller group ones on more focused topics. So Guy calls them coffee chats, where we're talking about, say, voice AI and other things as well. So yeah, don't worry about sign up. We're just in the process of basically figuring out what the agenda is from maybe September onwards in terms of the wider AI literacy. So any suggestions, feed in, and if you follow us on LinkedIn, we'll share information once we have it.
Perfect. Thank you very much.
Cool. Any other questions, or I'm just conscious of people's time.
Hi, Paul.
Hello?
Oh, there's okay. You go first. Sorry, I'll come in after.
Okay. So, hello, first of all, I'm really happy to hear from you, and the topic is really important for me because I'm a PhD student and just I'm working on my thesis, which refers to AI implementation in education, especially in English language teaching instruction. So I have a question. As a researcher, I'm going to implement AI tools and some kind of services in my school curriculum. So I really wonder if there are some free services for schools to use artificial intelligence tools in education. I'm from Georgia, and so it's really important for me because everything is based on our funds, and so if there are some free service, I would be really grateful to test it.
Cool.
Any
Thanks.
choice?
So yeah, just in terms of free stuff,
Especially for secondary schools.
so in terms of the stuff, I don't know if it's just restricted to the UK, but I know Old National Academy will launch a teaching lesson plan, but it's optimized for the UK. Which will be free at the point of use. And I know Carmigo and Khan Academy has just been made free in the US as well. One of the challenges is there is a cost to using these. So when stuff is free, it's either you are the product, as in they're using your data. So there is an option for people to use GPT for free, Claude for free with usage limits. What you've got to remember there is, there's no options to opt out of training data on the free packages. The other thing is, I spoke to an amazing Georgian organization yesterday called DocumAI, who are doing very good stuff on voice AI stuff. The other thing to say is basically, as a collective in the country, you can petition for a funder to cover the cost, basically. So at the moment, I know free tools in, say, the UK and in the US, and I also know the general purpose tools which you can access for free, say ChatGPT or Claude.
Gemini, maybe, right?
Gemini.
Copilot.
Highlight.
Gemini Copilot.
Yeah, but they have a little bit limited functions. So I more wanted to help with studying in assessment criteria. So I think in this case, ChatGPT isn't able to help us.
It's not the best out of the box. You can get it very good. So this is the other way that people proceed. You basically do prompt engineering, in which case, and we should do this, we should compile a list of prompt templates for people for this kind of entry-level free stuff, basically, because if you have a prompt which is 4,000 words, GPT-4, even the free version, is pretty good. So there is a kind of pathway into the free version, but it does require some investment in learning how to prompt and prompt templates as well. We can definitely, as I say, I know in the UK, the Old National Academy stuff is free, basically, but it's targeted for the UK curricula. That's the problem, because people are paying for their teachers. So generally, governments will pay for their teachers,
Okay, thank you so much for your answer. Thank you.
Hopefully in 6 months, we'll have a better answer, Nina.
Sorry?
I said, hopefully in 6 months, we'll have a better answer. Okay, any last questions or clarifications?
I want to give one input, if you allow me.
Of course, Uma. Yeah, of course.
Okay. The thing is with reference to the question the lady she was asking about feedback and secondary students classroom activities when it comes to giving them feedback. In UK specifically, when we are talking about Cambridge and all this curriculum, assessment for learning is the best tool, the best way to address formative assessment, ongoing assessment. And when you go to Copilot or Gemini, they give you few activities to address assessment for learning, in which feed forward, feedback, all these things are involved. So they are free, and we cannot use to the best of our abilities, but to some extent Copilot is suggesting activities for AFL and feed forward and feedback too.
Yeah, it
Mhm.
is. And one
Okay, thank you.
One thing we should do is basically share some good prompts. We have the prompt writing guide, but I do know that there are good prompts for quiz generation. So we have one, but there's a lot of good high quality prompts. The other thing we should do is crowdsource and say to people, if you've got a really good one, share it with us and put it on the website. All of these things are great ideas and something we can, as an initiative, definitely try to kind of improve upon. And I think that's a really useful summation because, as I say, part of what we're doing here is figuring out what people want by having these conversations and hearing from you as well. So just to kind of conclude, AI should not be kind of overwhelming for people. So how the AI systems work is really complicated, but what they're doing at its heart is actually very simple. And it's basically prediction. And that matters because they're really, really good at predicting what they've seen. And they've seen quite a lot. But the big question for us as educators and policymakers in education is, have they seen the things I think are really important? Because if they haven't, then we need to be thinking, how do we get that in? And then how do we judge quality as well? So thank you all so much for joining. This is the end of this current wave of training courses. We will be back and do a few more of these, and we'll do the coffee chats over the summer. We'll probably all try and take a holiday and relax and recuperate a little bit because it's been very busy, and then we'll come back in September, October time to do another wave. If people have any suggestions, any feedback, what you liked, what you didn't like, please feel free to reach out and share all of that stuff, and we can only get better. And the key thing is that we get better as a community. So thank you to everybody for your time. I know it's quite precious, and enjoy your weekend.